Thanks, Gaetano. Thanks to CAA, Jason, for your introduction. And the ideas on a safe system, shared responsibility. I guess my talk today is tailored in that direction. Oops, I need to press that button. I recently encountered an unexpected problem, and I thought, well, I'll just discuss this thing I encountered with you all, and maybe we can all help to, come to a good solution. I quite enjoyed David Weston from Merlin's talk. I can't help it, but it makes me think of the movie Blade Runner with Harrison Ford there in 1983 flying his hover car. And you've got all these orderly hover vehicles traveling around in their lanes. And he dives straight down, and that's what I feel like when I'm flying my Cessna 150, and I'm thinking, wow, all these autonomous vehicles going around, and I don't know what they're doing. Anyway, that will be, we'll all have to, I guess, adopt to the future. And so the FAST 23 Amendment 64, we had a little dabble in that in Aero Design. We did our first STC at Amendment 64. I noticed in 2019, in January, it was issued. New glass cockpit for a Cresco and electric wiring, so it's not that challenging, but, still it was quite, we dabbled with the same sort of questions. Is how do we show compliance? And a lot of it was just using the old rule, so it almost become a translation between 64 and 63, but then some of it we did benefit from 64, that's why we did it. Anyway, I better get on with the topic. I want to talk about 603 and 605, and this is one of these rules. I don't know about you guys, but traditionally you come across it and you go, oh yeah, it almost always applies to whatever new thing you're making. And with metal, it's typically quite easy to show compliance because we always use aerospace compliant metals, and you just tick the box. Yes, it is. It's in Mill Handbook 5 or whatever, and it's a ASI metal, it's specified and it's compliant. When it comes to composites, it's a whole different question because you're making the material. And a few years ago, about 5 years ago, we started with manufacturing and composites. We had a project to manufacture a carbon fiber wing for a Cresco, and this became a very relevant topic for us. We had a very unwise, commercially driven desire to use locally available materials and qualify it instead of using pre-qualified materials. In hindsight, pre-qualified would have been better. But in that process, we learned a few things, and we're going to have a look at that. Now, of course, there's new relevance to the topic of wanting to use alternate composite materials due to the disruptions in our supply chains, and that's what the topic is all about. So I had this little catchphrase maybe as an introduction. As a design delegation holder, if you're too compliant, you can be non-compliant. I'll explain that before we get to the end. As a play on words, this is a hint, so So we should just have a look at the intent of the rules and the challenges that we've encountered, what might be the causes of those challenges. We tell you a bit about our proposed solutions that we developed for Aero Composites and a background on what we've learned in the process, what benefits they may have, and what we as design organizations can play in this role. So I just, looking at the rule itself, I underlined a few words there. The suitability and durability of materials used for parts which could affect safety must. So it's not an option, and all three, A, B, and C, must be complied with, must be on the basis of experience or test, and must meet approved specifications, and environmental conditions must be taken into account. And similarly for fabrication, process specifications are required. Now, yeah, and there's AC 20107B for composite aircraft structure. It just explains a little bit that, extra care is needed when you're actually making the material and the way you procure it and how it's processed, because it can affect the structural properties. I'm just gonna, you can read AC 2320 yourself if you're interested. But so what happened here, I'll just tell you a bit about the problem. We got a fairly routine request from a manufacturer making a product out of composite materials. And they said, we can no longer find the original materials that this product was certified under. We want you to approve alternate materials for us. This is kind of very simple, run-of-the-mill, easy, minor, you would think. But then we went about it the way we know. We wrote the material spec and we prescribed the whole process and we submit the package to the customer. This is, what we propose to do. And we encounter a lot of pushback. And no, we don't want a spec. Just, up issue the drawing and call out the alternate material on the drawing. Okay, well, you can't do that. It doesn't comply with FAR 23603 or 27603, whatever the case might be. And they say, no, but that's how it is. It's on the current drawing like that. We just want the alternate material on there. And so, at the end of the day, we had to walk away from that job and possibly, have some issues with that customer going forward. And so I was just sort of thinking, well, what could be causing this problem that we encountered? So I think a lot of historical fabricators would just acquire composite materials and make their prototype, and they might test the product. And they treat it as commercial off-the-shelf materials. And then they select the materials based on a technical data sheet, which lists properties and may even list specifications to which it was tested and typical values you get. But as we shall see, technical data sheet is not a specification, and those technical data sheets only list sort of typical and oftentimes optimistic values because the material supplier wants to sell his product in competition with others, and he's not going to give you the minimum values, he's going to give you the more optimistic values. And then if you're going to buy from local composite vendors, they source their products from various suppliers. They don't always tell you when they change supplier, but they still sell it under the same part number. They may even have some resin decanting and mixing processes going on, and then they source some chemicals that they add or additives, and then they can't find it anymore in one place, and then they'll substitute it with another, and they won't tell you about it. We have encountered that with resins we used. After we tested it and qualified it, we found it's suddenly no longer meeting the properties that we were used to, and we were going back to the supplier and say, hey, what did you change? You know, why is it different? Oh, yeah, he changed supplier on one component, and so we forced him to go and do a spectral analysis, and although the materials were similar, they were not identical, and it affected the outcome for us. So we have these historical precedents. So historical precedents, what I mean by that is before supply chain issues, we used to be able to buy really good quality composite materials from America typically, or Europe. And you get, if not certified materials, you get materials from companies that normally make certified. And everybody knows that it's fine, it's not an issue, it's consistent. And we probably got away with a process that everybody got used to that no longer really meets the world we're living in because of all these supply chain issues and changes, and you may get less reputable suppliers in the chain. Now, of course, the rule has got this qualifier that this is only required for materials where the strength of the structure matters. And so we're going to have a little look at how do we classify it. And then, incomplete compliance statements and technical assessments can be causing this attitude with some of the fabricators. There's a very useful document on composite material, or on COTS actually, commercial off-the-shelf products for use in aircraft. I've got the link on there for you. Go and read it yourself if you're interested. I'm just, after reading it, I made this conclusion, and I've written those words in an email a long time ago, where I commented to somebody that thinking of commercial acquired composite materials as commercial off the shelf conflicts with FAT 2X603. By definition, the user of COTS have no legal right to subject the supplier to specification or requirements. He simply buys it or not. There's in that document this little myth buster written. We'll just demand that the COTS supplier strictly control internal configuration and dutifully let us know every change he makes. Wrong. By definition, the government, in the case of that document, or us as design organizations or manufacturers, takes COTS as it comes. And when it comes to configuration, we're just along for the ride like any other customer. So is it only big users of composite materials like Boeing who can use material specifications to force their supplier to to supply only conforming qualified materials. What about smaller companies like we have here in New Zealand? Can we do that too? Okay. So this is a bit of a wordy slide, but basically what it's saying is 603 and 605 applies to parts and materials that could affect safety if it fails. And that leads you to look at priority parts, primary structural parts, and the definition of those, which is given in car part 1, and there's a wording there. But basically, what I'm saying is to make a proper classification of something being structural or not structural will require a failure mode and effects and criticality analysis of your design. And it sometimes requires a little bit of imagination of how things could fail and how they could go wrong, and not just dismiss something as, it's secondary structure, it's not carrying the main flight loads, it's not that important. Here is an example of some secondary structure that came off. This is Continental Express Flight 2574 in September 1991. Lost control due to the separation of one of the horizontal stabilizer leading edges. No survivors. Now, would we typically classify aerodynamic fairings on control surfaces, leading edges, the likes as primary structure? Probably not. But if they fail, could they affect safety? Probably yes. So I would say, the humble aileron tip fairing, elevated tip fairing, rudder tip fairing, anything like that could be affecting safety and would need compliance with 603 as it stands. So I got a little exercise for you here. I don't know if you can read that, but I've put a compliance statement on there that is similar to things I have found in industry in my past. So it says here, the materials used are stainless steel, aluminium alloy, and carbon fiber. Suitability and durability of which has been established on the basis of experience in similar installations. Your delegation holders, anything wrong with that? Hey, John. Okay, I'll help you out. I know. I don't think the person who wrote, well, I modified it a bit, so it's not what anybody's written. It's just kind of reflects what I have seen in various places. Okay, so don't be worried about it. I won't reveal any. I try not to embarrass anybody, right? That's not my game here. It's just how to solve this problem. It doesn't mention that this product has been assessed to not matter for failure, right? So I guess it either has to say that a failure mode analysis showed that if this item fails, it will have negligible or no effect on safety. Then you can probably get away with neglecting further compliance. But if you can't do that, then I would say you should mention testing or what the experience is and what similar installations is claimed. I guess, typically we would be required to have the data when you make a similarity claim, and you should be able to quote the data that you have similarity with. And then this statement doesn't mention anything about subparagraphs B or C of 603 about specifications or environmental. And so that's, now, if we as design organizations can write this in a TA, I guess this is where my statement my opening statement comes in. If you're too compliant, you can be non-compliant. So in this case, you may be too compliant to your customer's needs, and you write something because you think he's okay, but you're not compliant with the rules. And that perpetuates the problem with fabricators who think, well, that's okay because that's how it's always been done, and it's been done like that before. So how do we solve this? Of course, the best solution is use pre-qualified materials. This is what we're doing standard typically in metal. You use a MS20470 AD rivet as an example. It complies with the specification, and it has a certified route of acquisition, and that's all well-known certified stuff. You can do the same with composites. There are composite materials being produced, especially prepregs, which are certified for Boeing and Airbus and other manufacturers, and they will sell you some of their product if you're lucky to get some of the production run. Unfortunately, it comes at a bit of a price, and there's lead times and problems like that involved. And you probably need to buy quite a bit to get into the play there. So if you want to buy small quantities, this is not a very good solution. There are suppliers like in America, there's Pacific Coast Composites. They would sell you small quantities of certified materials. So that's always, I would say, the number one preferred option. If you can do this. In our experience, too much headaches with using second and third tier suppliers. The second best solution is, of course, you buy unqualified materials from a reputable supplier, like somebody who's making qualified materials, but you're just buying one of their products that's more readily available but not qualified, and you write your own specification, you do your own testing, and you qualify the material. And essentially you're complying with the rule just as well. Now, for lower grade suppliers, you could still comply with the rule by buying material, but in a lower grade supplier you have a few challenges, like the material is not being qualified to any recognized specification. A mill certificate may not be supplied in all cases. You don't know, if the quality certification is very good. And so we can still use it if we write an acquisition specification. We do our own testing. You order the material with your acquisition spec, and you do conformity with testing. So you would probably have to do some sort of conformity test with every incoming batch that will ensure the material hasn't changed. And you can consider testing each product manufactured. That is a approach that can also help in a case like this. Just quickly, MIL Standard 490A is a specification or a standard that talks about specification practices. It describes how to write a specification. So if you need to write a specification, have a look at 490A. Recently encountered a good example of a specification. HS AS 9354 is a specification for the ISO EA 9309.3NA we so love to use to do metal repairs in aircraft. It is the official specification with the guaranteed minimum properties that you can use to design to. And it has the high temperature and humidity properties there that you can use. Here's just a little example of one of Aero Design's detailed specifications, just a table of contents, just to give you an idea of what is in a specification like that. Material qualification process usually involves writing a draft material specification, selecting some materials, manufacture test coupons, do testing. If it's acceptable results, you update your specification with the test results, and you continue on using that material and certifying your product. If it fails your testing, you're going looking for another candidate. Now, this is getting towards the end. So, the benefits of complying with FAR 603 and 605 is the obvious one is you're complying. And then, of course, there's simplification of drawings, ease of adding alternate materials, so you don't have to update all your drawings. Every time you add an alternate material, it's just the specification updated. You get improved part quality, reduced scrap, reduced failures, and warranty issues, increased profitability, and increased safety, the bottom line we're all here for. I'll skip over that. So what can we do as design organizations? If you don't want to use qualified material to 603 to the full extent, at least you must do a FMICA to determine if the part actually is in the classification where failure wouldn't affect safety. We would like to see that we all encourage compliance in the industry. When we write our technical assessments, keep in mind that we should, fully consider all the paragraphs in there. And maybe we can just discuss this topic amongst ourselves later and get sort of a more unified, standardized approach to specifications. That's us.